Alright, guys, let us look at another September question paper 2023 from Limpopo, and we are at question 2, and this is what we have. We are still looking at inclined plane. They say a block of 2 kilograms is sliding down a plane inclined at an angle of 30 degrees to the horizontal as shown in the diagram. So this is just a basic problem. These are the problems that you will find in grade 10, grade 11, where just one block is given, and this is a block of 2 kilogram, and they tell you that it accelerates in that direction. Acceleration is a vector, and they say in the first problem, the coefficient of kinetic friction, which is mu k between the block and the plane, is 0.2. So mu k is 0.20. That's fine. Define the term kinetic friction, frictional force. I'm not going to define that. That is for you to look up in your manual. And then in 2.1.2, draw a labeled free body diagram for the block whilst in motion. So this is very, very important that we see and understand this, right? What I'm going to do in drawing a free body diagram, they are not being specific. Let me check. Yeah, whilst in motion, so they are not very specific whether we should draw a free body diagram showing only the forces that are doing work, or we should show all of those forces. So I think it will be convenient to draw two diagrams just to show exactly what is happening. So I know that it accelerates downwards. So if it is accelerating downwards, and I know that a free body diagram is represented by a dot, I know that there is weight which is always acting downwards. This is the first thing. I can say weight like this, or I can say mg. You remember, I can say that, or I can say fg. Okay, and then I know that this object has a normal force which is counterbalanced by fg perpendicular. So I can have my normal force, which can be very equal to the weight since they are not doing work. So I can have my Fn like this, or capital N in that way. If you remember from the first lecture where we dealt with incline, I explained all what I'm writing here. And I know as the object goes down, because there's no force applied, meaning the component of the weight is responsible for moving the object downwards, but because the surface is rough, because I'm given mu k, I know that friction will always oppose the movement of that object. Okay, so okay, that's fine. I will have my Fk. This is the force of friction, or I can write this as Fk with capital Fk. I can write it like this: capital F, small fk. So let me just fix this. I can say F and Fk. I can write it in this way. And then this is me drawing up this and as a free body diagram. This is the first diagram that I can draw to show that this is a free body diagram, where I excluded the component of the weight. Or I can come here and say, okay, I have a normal, I have a weight, and I can say the normal force is counterbalanced by Fg perpendicular. Okay, and I can say, all right, I know that I have my force of friction, and I can say, okay, since the object is sliding down, I know that what is responsible for this is mg parallel or Fg parallel, and I know that it has to be shorter than this. That is fine. And having said that, we are more than fine with this, very much more than fine. Okay, that's fine. And then what does the second question require? Calculate the acceleration. So in 2.1.3, calculate the acceleration of the block. Now the acceleration of the block, Newton's second law, the net resultant force is the product equals the product of mass and acceleration. So taking into effect in this, we are just concentrating on the forces that are doing work, which will be much clearer in this one. The object is not going up or down, so this and this and this are not so much doing work, but the component of this, which is this, is doing work because it is responsible for pulling the object down because there's no force applied. So I'm going to write this as positive. Mg parallel, they are in opposite direction, minus Fk, those are the only two forces, equals the mass of the object, which is 2 times the acceleration. Okay, be that as it may, I can try to say, okay, mass is 2 times 9.8. I know that mg parallel is the sine of the angle. The angle is 30, minus, I know that this is mu k times the normal force, but the normal force is equals to Fg perpendicular, which is mg, the cosine of theta, and this is equals to 2a. So 2 times 9.8, the sine of 30 minus 0.20 times mass 2 times 9.8, the cosine of 30 degrees, 2a. I can find the value for this. Let me go to the calculator very fast. Where is it? Here it is. I can say 2 by 9.8 by the sine of 30, and I'll find 9.8. This is 9.8 minus, let me find this. So all I have to do is to replace a sine with a cos of 30 and multiply that by 0.20. That's all. I just have to say 9.8, the cosine of 30, times, let me check if this is all correct. So this is 2 times 9.8, the cosine of 30, times 0.2, and you'll find a value of 3.0 3.39482. 3.39482, that is equals to 2a, and these are both numbers, so you can just say 9.8 minus the answer, and you will just find 6.4051828. You can divide both sides by 2, and you will find an acceleration of 3.2, correct to 2 decimal places. That will be 3.20 meters per second squared. And now we did not specify the direction. Where is this going? So the acceleration will be 3.20 meters per second squared, and this is positive, so it is going down. And this will be your acceleration. Okay, that's fine. Even a grade 10, even a grade 11 student would have been able to solve this grade 12 problem. And then we are done. We are done with this, and I will see you in the next tutorial.